Thanks everyone for coming tonight. It's great that you're all here. So the setup is a little bit different to normal Zoom meetings that I've had as well. This is my first time. We decided to do it via webinar. That's because we expected potentially 80 people. I think 35 have signed up, so I guess that's just what happens with a free event. But we thought with so many people, it would be a bit tricky for there to be lots of videos. Also, there's some really great poll functions that you can use with the webinar type approach on Zoom. So we decided to go with this. Hopefully it works for you all. Matt and Liam, do you want to turn your video on and say hello for a moment? There's Matt. They're our tech support. So if you have any issues.
Hi there, Rick.
Hello.
So
we're just here to do the sort of technical side and to support Anika so that she can focus on giving the presentation, basically. So any problems, just get in touch with us and we'll do our best to help.
So the way that we're going to manage questions is there'll be a number of approaches. So one, you can use the Q&A box. Has everyone seen the Q&A box? So that would be the best way to ask a question. Also, you can put your hand up to ask a question, and then we'll be able to see whose people's hands are up. I also might ask you to put your hands up in response to a question that I ask. So it would be great if you could engage in that way too. And then if you have a question, well, at a certain point in the presentation, we'll take a few questions from you. So if you have a think about any questions that you've got, write them in the question answer, and then we can also, you can ask them live as opposed to just typing. And so the chat box, which we've been talking on to date, have been, that would be best if it could be just used for technical questions, because that would be easier for Matt and Liam to keep an eye on the chat for technical questions. And then any questions about the content, keep to the question and answer box and using your hands up, and then we will, and we'll be able to take questions from you, sort of speaking questions. Hopefully that all makes sense. Also, it'd be nice for the question and answer box. You don't need to just put questions, you can also put comments. Obviously, this is the first time I've ever done something like this, and normally when I do this training in real life, as in person, it's good to get feedback from people. So it'd be really nice if you have any thoughts or just general impressions to just pop them into the question and answer box. And so by technical, yes, we mean IT technical, not building science technical. If you could keep all content questions to the question and answer box. And as I said, it doesn't have to just be a question, it can be a comment. So there is another Q&A box. If you go to the bottom of your screen and sort of, I think there should be the sort of menu at the bottom, it should say Q&A. So Matt can sort of help you with that if you've got questions. I could lower my screen, I'm on the bottom of the image. Okay, great, is that better? Oh, I'm also recording this event, or I should check that I'm recording it actually. Oh, that might be the host. So Matt, if you could check that this event is being recorded, that'd be great. And we'll also be having a break in about 10 to 7, because I think looking at screens and concentrating for a long time is a lot harder in a classroom. So we'll have a 10-minute break at that point. So, great. So I will make a start if that's okay with everyone. So, let's see. Do introductions first. So about Carbon Co-op. So I think lots of you will know Carbon Co-op, but for those of you who don't, we're a Manchester-based organisation. We're a cooperative made up of members from around Greater Manchester, who are all residents wanting to do something practical about climate change through improving their homes and saving energy at home. We've also do lots of quite a wide range of different kinds of work these days, so around energy systems work, around energy democracy, as well as around retrofit. But part of our work are running trainings. So with everything that's going on at the moment, we decided to run weekly webinar series. And obviously everyone's spending a lot of time at home. So we thought something around indoor air quality and general home health would make a lot of sense. About me, I've worked in Carbon Co-op for about 4 years now. And my role has been mostly within the retrofit team, working with the membership, developing a training program, and now I'm doing lots more work around contractors, sort of supporting the supply chain around retrofit. But I thought it would be quite good for me to get a bit of a sense of who you are too. And given there's lots of you and we can't exactly do a go round, I've done a question. So Matt is going to send you all a poll, sort of a question poll. Now, if you can't see it, this is the time you can use that chat box to say it's not working. It has been a bit glitchy, Zoom and polls, so do let us know if it's not come through. So I'll give you all a minute to do that. And also, while we're waiting, just to say with the questions and answers, you can rate each other's questions. So if there's a question you really like, it will raise the top of the list. So no one can see a poll yet. Let's just check that Matt's putting that. It should just appear on your screen. So we will.
I will end it and try it again.
Yeah. There we go.
Yay.
So there's 2 questions there. You have a go at answering them. So give that a few minutes to do its thing. So I think Matt will just be getting the responses from the poll now, and then he'll share it with us so we can have a look at where people are. So we've got a lot of homeowners, a few renters. Most people are here because they want to make improvements to their homes. There's quite a few people here with a professional interest. Some people specifically around ventilation, and some people are just interested. So that's great. So it's good to have an understanding for me and for you all to sort of have a sense of why we're all here. So let's see. Moving on. So what we'll be talking about today, firstly, sort of some kind of broad stuff around retrofit and energy efficiency. So I'll be talking about the whole house approach and what we mean by that. And then we'll be looking more in detail around indoor air quality and health. And I think after that section, we'll have a break. And then the second part, we'll look at some of the basics around ventilation, some things around standards and regulations around ventilation, and then a more detail on ventilation systems, and then a little bit on what you can do now. So hopefully that's what you think you've signed up for, or if not, hopefully you find it interesting. So the whole house approach. So this is really to help us understand our houses with a kind of understanding the complexity of them. So, you know, in a house, it's a system where we lose heat through the fabrics. That's kind of the walls, the windows, the floors, the roofs, as well as losing heat through drafts and sort of through air gaps. We also have ventilation systems in homes, whether that's opening a window or an extractor fan. It's some kind of planned form of air movement through your house. As well as that, we have heating systems. Most people have sort of gas boilers, but you can have all kinds of heating systems. Then we've got our lighting, appliances, things like solar PV. And then we have us, which is a really important part of the picture. It's not just about the systems of a house, but people and how they behave and how many people are a part of it. So the idea around understanding a whole house approach is the fact that all of these different systems interact with each other. Sometimes in ways that are easy to understand, but actually when in terms of what might happen when those systems interact, it can be sometimes hard to predict. So within sort of thinking about making home improvements, we really need to start to think about the complexity of homes and also think about risk. So we really take a risk management approach. So this means, sorry, I'm just gonna, yeah. So the idea of taking a risk management approach is not to, is to be aware that risks are there and that we need to sort of try to understand what unintended consequences might arise from those risks. So on the right-hand side of this screen, there's the wheel, it's a kind of responsible retrofit wheel. I would really recommend using this link, and I'll share the presentation afterwards, and having a click, you can sort of click on the different aspects. So ventilation, or you know, insulation, internal wall insulation, external wall insulation, and it will sort of show you, how different aspects of your home link to other aspects. So it's a really interesting little tool if you want to have a look. So the other part of taking a whole house approach that we think is quite important is taking a fabric first approach. So this means that you actually, hands up, who's heard of a fabric first approach? Let's test out this hands up thing. So we've got Sophie, there's quite a few. Brilliant. Thanks for engaging, this is great. Okay, you can put your hands down. So fabric first, I won't go into it in too much detail because quite a few of you know, although quite a few have done it as well. It basically means reduce the amount of, sort of make your fabric efficient before looking at other aspects of energy efficiency. So before looking at heating and things like solar panels. The purpose of that is because if, say for example, oh, whoops, I'm going too fast. It allows you to more effectively plan your services. So for example, if you are you want to sort of improve your heating systems, if you know how much you're going to reduce the amount of heat you need through things like insulation and air tightness works, then you'll know how to size your insulation system, your heating system, or you'll sort of have because we're here talking about indoor air quality and ventilation, you know, the kind of ventilation system will become more apparent after knowing what you're doing, what level of air tightness you're going for. So it's important to sort of consider air tightness, insulation, and window sort of improvements as a sort of first step. This also reduces your ongoing living costs. It can sort of, if you get this work done well, it can lower the amount of maintenance you might need to do. It also means that we are living in warmer homes that are healthier and more pleasant, and sort of it potentially avoids this kind of, we'll get a solar panel without thinking through kind of how much heat, or how much energy we use in our home, where we use that energy. And actually, if you look at the kilowatt hours on your gas bill and your electric, if you use gas, your gas bill and your electric bill, you'll see that you actually use far more energy heating your home than you do through appliances and lights. So it's definitely more a more hard-hitting way to reduce your energy use. But if you're also looking at strategically, it sort of has potential to reduce fuel poverty through improving homes. We get to future-proof our homes, dealing with sort of overheating in summer, flood risk, things like that. And also, importantly, it makes it easier for us to achieve the carbon reductions targets we're aiming for if we reduce the amount we need first, rather than relying on sort of heating technology to meet those targets. So you may all agree or not, but this is the approach that we take. So when looking at buildings, it's important to understand that buildings have changed quite drastically over the last 100, 150 years. So this image on the right is quite a good example of this. You know, in the past, particularly with sort of Victorian buildings or traditional buildings, you know, the buildings were designed to be breathable. They were heated using coal fires that relied on drafts being pulled through the building. But now we have central heating and we do a lot of air tightness work, and therefore sort of we don't actually want those drafts being pulled through the building. And we actually, in these cases, we end up getting lots of damp and mold problems because we don't have those drafts constantly going through the building. And that's where ventilation becomes more important and is kind of needed now in ways that weren't needed when the houses were originally constructed. So I think it's important to sort of understand the construction of your building and how it works when thinking about things like home air quality and ventilation. So the other thing to think about when taking a whole house approach is making a plan. And so that doesn't necessarily mean that we do everything at once, but it means that we have a plan to do things in a staged way. So you might think, I actually really, really want this kind of ventilation system, so I'm just going to put it in. But if you haven't thought about how you might be making other types of changes to your home, it might be the appropriate approach, or it might not. And if you haven't sort of had a a whole system think about it, then you might not make the right kind of decisions. So it's about sort of thinking about these things holistically. So are there any questions so far? I've lost my Q&A box. Here we go. No, okay, well, I'll carry on then. So it's probably this figure of how much time we spend indoors will be higher at the moment, actually, given that we're in a lockdown situation, but we spend a huge amount of our time indoors, and sort of the risk of indoor air pollution is actually quite serious, but not one that people often think about. So, you know, it can lead to things like asthma, headaches, shortness of breath, all kinds of sort of allergy type interactions. And also with sort of this, with the coronavirus going around as well, good ventilation systems are quite important too. So it's a good thing to be talking about at the moment. There are various things that impact indoor air quality. So I'm going to spend a chunk of time now talking about moisture, because it's kind of one of the most significant ones. It's produced a lot by lots of our daily activities. So, you know, just existing in your home, you breathe out water vapor from, I don't know how many people watch the videos, but it's got a really nice illustration of this. And plants will breathe, animals, drying our clothes indoors, having showers. And obviously we can change our behaviour, but we can't stop existing. So we're always going to have moisture being created in our homes. And particularly coming from places like Manchester, they're very damp and there's sort of issues with water around our homes. The relative humidity is quite high for quite a lot of the year. And I'll explain what relative humidity means in a bit. So don't worry if you don't quite know what I mean by that. So there's lots of ways in which the moisture can, you can create moisture indoor from your activities, and also you can get moisture from the outside coming into your home. So in this context, we think it's important to really consider ventilation. So internally, the ideal relative humidity should be between 40 and 65%. So if we have a look at this, this is a really good graph, I think, to show what this, when I first saw this, it really impacted me in terms of understanding why people pull out this figure of 40 to 60%. So on the right hand side, you can see various aspects that impact our health: bacteria, viruses, fungi, mites, chemical interactions. And you can see that in very dry environments and very wet environments are where these kinds of issues really thrive, and there seems to be a kind of optimum zone of around 40 to 60, 65% in which these interactions have less impact. So I think that really helped me when I first sort of looked into this, understand why relative humidity is so important and why those numbers are so important. So I've been saying relative humidity a lot, and some of you might think, what is that? So it's a measure of how saturated the air is with water vapor. So at 100% relative humidity, that's when water droplets are formed. It's a dew point. So that's kind of how rain's formed. And warm air can hold a lot more water than cold air. So this is really important in terms of thinking about relative humidity. So this is a nice diagram here where you can see, so at 10 degrees, say a water molecule and the sort of corresponding sort of amount of air can hold it sort of fills the whole space. The holding capacity is filled. And so we've got 100% relative humidity. But say at air that is warmer, 30 degrees, the amount of sort of water that the amount of space, for want of a better way of explaining it, that the water can hold in that 30% of air takes up 20% of 28%. So it's kind of, you get this 28% of relative humidity. So it's important to understand the relationship between temperature and relative humidity. To explain this in a bit of a better way, I'm going to show you a specific point of this video because it does it really well, much better than I managed to do. So I'm going to play this.
Different temperatures, air can hold different amounts of water vapour. The warmer the air is, the more moisture it can hold, known as its holding capacity. But when there is more water vapour than can be held by the air, it becomes full up and condenses, into liquid water. Outside of your home, this is how rain is formed. This also happens when warm, moisture-rich air meets a cold surface, like a single glazed window in your home during winter. Condensation forms as the air suddenly cools against the surface and the holding capacity of the air is reduced. Because air can hold different amounts of moisture at different temperatures, we measure how full the air is by something called relative humidity. If we have 100% relative humidity, then the air is full up and the vapor becomes liquid water. But even when there is no condensation, high relative humidity can be uncomfortable and lead to mold and other problems. At the other end of the scale, air with 0% relative humidity is excessively, and in fact, impossibly dry and uninhabitable. We need a relative humidity of somewhere between 40% and 65% for most of the time for the building atmosphere to be pleasant and healthy. So we come back to balance. Not too dry, not too moist.
Okay, so I'll leave that there, but hopefully that's helped explain the relationship between temperature and relative humidity and water vapour. So, yeah, this shows that there's an inverse relationship between temperature and relative humidity. So air that's very warm will be drier and air that's very sort of cold will be wetter. So again, are there any questions? Sometimes this can be slightly hard to understand. Okay, no questions. Actually, just one second. So this is a graph from quite an interesting case study. So about a year ago, we did a project in Salford where we put some temperature and humidity sensors in 4 homes for four people we were working with, and then supported some local handy people to learn how to do draft proofing through putting a blower door, doing a blower door test on their homes where you sort of pull all the air from the homes, you can see where the drafts are, and then they did some draft proofing. But we also used the temperature and humidity sensors to talk with the residents about their homes and their home use. So in this example, when I showed the person who lived in this house this graph, which was of her her environment. So the blue is the relative humidity, and the orangey yellow graph is the temperature. So as you can see, that as this was the point at which we asked her to heat up our home to 20 degrees for the sake of the test, and you can see there's a big drop in relative humidity. And so I showed her the relationship between the both, and I sort of asked her a bit about her lifestyle and said, oh, where do you dry your home clothes and how warm do you, to what temperature do you warm up your house? And she said, well, I dry my clothes all over the banister and generally we keep our thermostat down to about 16. And I sort of said, well, maybe you should dry your clothes in your bedroom and possibly turn the heating up a little bit. And you can see that was it was in the mid-January when I gave her that advice, and you can see the immediate impact it had on her home, where her relative humidity went from between around the kind of 65 up to 70 point, right down to near the 60 point. And it's quite incredible to see the impact of just those 2 small things and what they can do in terms of changing the environment home. And after that, she said it was incredible to feel the difference. She'd always felt her home was really damp and cold. But I'm not saying this will be the case for everyone, but it gave me hope there are actually some sort of simple things that you can do to manage moisture at home. So the other thing to think about is the fact that throughout the year, the relative humidity outside and the absolute humidity outside will change depending on the season. So in the summer, relative humidity is generally lower, but the actual amount of water in the air is quite high, and the temperatures are also higher. So the air doesn't actually get to saturation point. In winter, relative humidity can actually be quite high, and I tested this winter where I put my humidistat outside, not humidistat, hydrometer outside, and it was 98% relative humidity. But inside, because it was quite cold outside, I think it was around 0 degrees, and as inside the temperature was about 18, So if you think about the relationship between heat and, relationship between warm air and sort of relative humidity, as we warmed up that very humid air outside by bringing it inside, the sort of relative humidity was quite low. That's why you can often feel it feels quite dry inside during the winter sometimes. But the important thing the reason why I'm talking to you about this is if you start monitoring your humidity levels at home, in winter, if you find that your humidity levels are quite high, it might suggest that you've got a significant issue. But if you find your humidity levels sort of on the higher end during spring and autumn, where if you think about it, the temperature outside might be something like 16 degrees or even 14, but as you bring it into the home, you're not heating it up that much. So we don't have that opportunity to sort of get our relative humidity levels down indoors, if that makes sense. So that's worth considering, to not be too worried if you get sort of higher levels of humidity in spring and autumn. That doesn't mean that you shouldn't take measures to reduce the amount of moisture you're producing in the home or think about ventilation. It just means you shouldn't worry about it too much. So I think I've just said that. So again, are there any questions? Okay. Actually, at this point, shall we do the poll? Matt, do you want to do the second quiz that I have? There we go. So here's your chance to check whether you have been listening to me. Yeah, if you'd like to ask questions, do just raise your hand and then we can unmute you and you can ask the question. We'll just wait to hear back from... So we've got our results. So the first question, air in winter is often very dry because there's less moisture in the air at this time of year. So we've got about a 32, 68% split. So that's actually, the right answer is false. So this is indoor air. I apologize, actually, the phrasing of the question. I meant to say indoor air is often very dry. There is actually a lot of moisture in the air at that time of year outside, but as I said, as you heat up that air, it's you have a sort of lower relative humidity indoors. So the best ways, as if anyone doesn't understand that, it would be really great for you to just raise your hand or pop a question in. And there are a few questions here. Are humidity tests affordable? Yes, they are. They're about £10 from, I bought one from Cass Olsen. You can get some online. I've got a thermometer and humidity gauge. Yep, that's the one. Yes, that will. If it's a percentage, it will be measuring relative humidity. And if we turn up our heating to reduce relative humidity, will that use more fuel, which is also a bad thing? I mean, that's an interesting question. I think in terms of the temperature of your home, we'll go on to talk about more reasons why that's important. There is something about air that's less humid being easier to dry, easier to heat as well, because there's less substance in the air to heat. So that's, there's also, it's kind of a bit of a toss up. Best ways to reduce mold growth in the home are, so there aren't sort of hard and fast answers to this, but I wanted everyone to sort of have a think about the different ways that you can reduce moisture, you can reduce mold growth. Most people think we should try and keep the temperature of our homes up. that sounds good. I guess you've taken that from what I've just said, and also about the drying clothes. Using a dehumidifier is interesting. I think it's a good sticky plaster solution if you really don't have another option, but it's not a long-term solution because it needs to be on all the time, and really you probably need to sort of look for ways of reducing the moisture you have in the home through your behaviour or through ventilation systems, really. Monitoring humidity levels is a very good idea. Insulating, so obviously moulds, if you think about that idea that as air cools, the relative humidity goes up and you might get sort of 100% relative humidity is a dew point. So it'll be the coldest surfaces in your home, as you'll probably know, where mold grows. So doing things like insulating or making those those areas warmer will make a difference. So there are some questions from people that, so yeah, let's go for it. Paul, you've got a question.
Oh, you've asked me to unmute my microphone. You just said that if you insulate the walls, it'll keep the walls warmer, which will help. I'm thinking that you've really got to insulate every bit of the walls, otherwise you'll have some cold spots which will massively attract moisture in that circumstance, won't
Yes, that is correct.
Yeah.
I guess the other benefit of insulating is that it reduces heat loss. So your home, it'll be easier to keep your home warmer.
Oh, yeah.
But you're right, those you do get, that's also why it's important to try to create a continuous insulation layer so that you don't get those sort of cold points at junctions that then you get mold problems in.
Yeah.
Great. Does anyone else has a question, like to ask it? Okay, I'll carry on. So as well as moisture, there are other reasons there are other sort of indoor air pollutants that we're thinking about. If you've got a fuel burning appliance in your home, so either a wood burner or a gas stove, often we all sort of, you really should have those rooms. Normally you have to make sure there is ventilation in those rooms with things like gas burning stoves. You can get particulates that can aggravate things like asthma and other conditions. If anyone's got a wood burning stove, make sure that you have a carbon monoxide monitor and it's got its batteries in and it works. That's very important. And also, not for us so much in Manchester, but certainly in many other places in the southwest and Wales and further up in Yorkshire, things like radon gas is quite an issue. So this enters a home through the ground and through the floors. And if you're in an area of high radon, you definitely need to think about having a radon barrier, as well as ventilation that supports radon to be removed. Carbon dioxide is also created through fuel burning appliances and through breathing. And really concentrations should be below 100 parts per million. So I think you can get carbon dioxide monitors, but those are much more expensive than hydrometers. Yeah. So other sort of sources of indoor air pollution, things that need to be controlled. So volatile organic compounds, VOCs, you can get them in paints, new mattresses. I got a mattress recently that was it smelt so bad that after even 3 weeks of trying to air it that we had to send it back. New carpets, new sofas. Obviously there's mold and mildew. Even things like the washing up powder, other cleaning products, pollen, dust mites, or just sort of smells from cooking and bathroom use. So there are other reasons for why we want to control our sort of how we manage indoor air. In terms of things like VOC, it's a really good idea to control them at source, so reduce the amount that you try to buy low VOCO paints, and things like that. And also not necessarily dangerous, but pets and things like that we want to sort of control. So I've actually moved through this quicker than I thought, so I'm going to ignore that 10-minute break and we can come back to it in a bit. So talking about, actually maybe this is a good point to again check if there are questions. So there's a question here about mold growth where the ceiling meets the walls caused by a ventilation gap when laying loft insulation. So yeah, that is an interesting one. Something that you can do is put internal wall insulation sort of just along that sort of junction between the floor and ceiling. I couldn't give you too many details about that now, but there are ways that you can sort of cover that area. I don't know if that answers your question. Where does radon come from? I don't know. Sorry about that. Somewhere underground. I don't know if there might be another person that knows where radon comes from. If you do, feel free to jump into the question and answer box. Is there anyone else want to ask a live question? So I will, I'll move on. So ventilation basics. So when thinking about ventilation, there are two basic types. So purge ventilation and background or trickle ventilation. There are also two basic methods, natural and mechanical. But obviously there are lots of variations within these types that I will talk through in more detail. So for example, actually just to explain purge and background. So in a typical home where you might not have extraction fans, a purge type of ventilation might be opening the windows when you've had a shower or when you're cooking. And background or trickle would be the trickle vents in your windows. And yeah, natural ventilation, again, that would be something like opening a window, whereas mechanical involves some kind of motor. So it's important to understand the difference between ventilation and draft. So often some people think, well, I live in a really drafty house, so I don't really need ventilation. This might be a good time to try out the hands up. So hands up if you think, because you live in a very drafty house, you don't really need to think about ventilation. Definitely got a couple of people. I've definitely had that question a lot when I've done these presentations before. I think the thing to understand is that drafts are unplanned, whereas ventilation is something that you control and is planned. And so even if you have a very drafty house, you might actually have parts of your house that are quite stuffy and aren't well ventilated because it's not been planned. Also, it's important to consider that if you've got lots of warm, moist air and you've got lots of gaps and cracks, that's taking warm, moist air into your building fabric where it can then cause problems. So quite a typical example of this is lots of us, including me, have downlights in our bathrooms, which are sort of just underneath the loft. So if you sort of consider you have a shower and that warm, moist air gets around your around that downlight and then ends up in your loft space where it's cold and then condenses, and then you might get issues with your sort of structural beams up there or some of your moisture, your loft insulation getting wet. So it's important really to sort of make our homes as airtight as possible and reduce these areas where drafts come in and out, and then consider a controlled form of ventilation. But it's also important to realise that there's a difference between construction ventilation and sort of in the constructed building elements of the house and ventilation from within the lived part of the house. So for example, we have generally, if you've got suspended timber floors, you'll have an air brick, or we have ventilation gaps, as someone just mentioned, in terms of in the loft eaves. And sort of, yeah, it's important that those ventilation gaps are not covered up and kept in. But that's the kind of ventilation that we're not talking about today, because it's outside of what sort of designers call the thermal envelope. What we're talking about is a warm space within the house. Purge. So purge ventilation. So I'm just having a look at this. Purge is where you change the air in a kind of, so you've had a shower and you've decided to open the window, or you have a humidity stack controlled fan and it's gone to boost because there's a lot of humidity in the bathroom. that's purged, whereas trickered is a kind of constant background ventilation. Right. So, as I said before, protecting the building fabric. So here we can see, I'm just moving these chat boxes out of the way. So if you consider that you might get that you don't want to let warm moisture in your building fabric. So there's something called interstitial condensation, which is where you have this sort of graph shows a kind of cross section from inside to outside, and as warmer air travels through your fabric, there'll be a point at which it condenses. And I see that where it says condensation plane. And it would be at that point where you might end up getting structural issues if you let warm moist air into those areas. So that's another reason to sort of, one, ventilate, but two, do sort of try to draft proof. Also, I think this is going to become a bigger issue that we might, as we sort of saw a couple of summers ago, overheating is becoming a bigger problem, and it will continue to become a bigger problem. So alongside sort of a sensible shading strategy, staging glazing strategy, ventilation can sort of support us to not get too hot in summer. And as I said before, as we start changing the dynamics of our building through improving its energy efficiency, we sort of need to think about trying to reduce the amount of risk as possible. We're trying to reduce risk to our building as we do that. And you know, there's a good quote here from Colin King who says, any retrofit project that doesn't consider ventilation is basically a condensation project. So let's not go down that route. That's been gone. This is kind of what's been learned over the last 10 years. That, you know, thinking about ventilation, particularly if you're making home improvements, is really important. Some people, I don't know, another hands up, do some people feel sort of confused about, well, we're trying to keep our homes energy efficient, and if we start ventilating our homes, we're going to lose lots of heat, so it reduces the sort of impact of us trying to save energy. Okay, we've got a few hands. Yeah, I often get that as a comment. I think within this, we have to sort of not be too single-minded about things. So really, our bigger aim is to try to create a home that's, as well as being energy efficient, is pleasant and healthy to live in. So for us to be able to do that, we have to have healthy indoor air environments, and that has to involve ventilation when we think about things in a whole house way. Does that make sense? Those people that put their hands up, would you still put your hands up, or are you not so sure? Still not sure a bit. How to achieve the balance. So yeah, that is a good point. It's important to sort of, well, as we go through the ventilation systems, well, hopefully we'll be able to see there are different types of systems that are appropriate for different types of levels of air tightness and levels of sort of different types of homes. So hopefully that will help achieve a balance. It will help you understand how best to achieve it. And with these things, it's hard to be perfect, so we sort of do our best. I've been talking about air tightness a lot. This basically means sealing up all the gaps and cracks in your building to reduce heat loss. Where's the next? There was a slide in here which seems to have disappeared. But the reason why, a good way to think about this, and it was a way that helped me think about this, is if you imagine a kind of old cardboard box that's a bit rough around the edges, has got gaps in quite a few places, and you put an extractor fan or some sort of fan in one point and a gap in the other point, and you imagine the air flowing through the box, you can imagine it doesn't flow so well because it's kind of coming in through all the different gaps, and it's not such an easy flow. And then if you imagine a box that's kind of a completely new box, totally sealed, and it's got one inlet for air and one extractor fan, you could imagine sort of what the airflow will look like as it goes through there. And I think that's a really good illustration of sort of understanding that if your ventilation system has to be, your ventilation system will work better and more efficiently if your home is more airtight. Actually, maybe that's at the end of the next bit. So before we move on to, it's been 45 minutes. Maybe we should have a break at this point. So I'm going to take a sort of, if we say we'll come back in 10 minutes, and if anyone has any questions in that time, please do pop them in here, and then we'll be able to get on to the next section. Okay, I'm going to guess you're all there. There's been some really interesting questions on the question and answer section. And also I'd really encourage, if anyone wants to actually speak and not type, I really would encourage you to put your hand up, and then Matt or Liam will see, and then we can take your questions in person. I think I'm going to have a go at answering some of these questions, the question and answer section. The first one from Paul is quite a long, big one. He's basically, I think what you're saying, Paul, is that given that there's going to be lots of support around thinking how to do this stuff properly, do we really need to think about all of this stuff ourselves? And can Carbon Co-op not help us, support us through this process? I guess I would say that there is going to be a lot of support around this. I think PAS 2035, which is a kind of government, a new sort of retrofit standard that was brought out last year. I think it was last year. I don't even know what year we're in. It's been also thrown up around. I think it was, yeah, definitely last year. At the moment, that's only applying to publicly funded works. That's not really applying very much to individual householders. We are sort of developing a service based on that for householders, but there'll be a lot of people that won't necessarily want to engage that service, but will still find this information useful, I think. So I think it is good for us to get our head around it. And also I think in terms of understanding the physics, I mean, we're all different, but I certainly have felt that from understanding the physics, I make choices around my behaviour at home that have made a difference to my living environment because I understand how it works better. So I think there is a value to that. In terms of what we would charge, I can't answer that question, but certainly get in touch with us at info@Carbon Co-op if you want a bit more on that, and we could do our best. This question about whether it's a good idea to open the window after a shower, I think that's a really interesting one. I think if you have no ventilation system, it's your only choice. So it's kind of what you have to do, but it's not really an ideal choice. And when I've done this webinar before, or not as a webinar, as a training, people have said, well, I don't need a fan because I just open my window and it does the job. But you're right, because actually by opening your window, you're cooling down that room, particularly if it's cold outside. And if you're cooling down that room, that means the dew point will change. So if you think colder air has a lower holding capacity for water, you're more likely to get mold growth in a cold space than you will in a warmer space. So it isn't the best idea if you have the option to have a ventilation system that works. It's definitely better to have a ventilation system. Obviously, if it's your only choice, and it's kind of what you have to do. Someone sent in a question about open chimneys. I think, yeah, it's a really, really, so in terms of whether they help with ventilation, so if you, like I was saying about old houses, so if you have an open chimney in an old house and you heat your primary source of heating is through using that open chimney like they used to 100 years ago, and you have fires in there every day, then you need drafts coming through, and that's how your house stays warm, that's how it functions. But I'm guessing you've got central heating and you don't use your open chimney that much. Feel free to comment if you do use it every day, but if you don't, I highly recommend getting something called a chimney sheet or a chimney balloon. It'll probably be the best £20 you spend, and I sound like a salesperson, but it's true, because actually the amount of heat everyone loses, if you've got an open chimney, the amount of heat you lose up that chimney would be, someone did, I don't know if anyone has Diane Hubbard, but she did her dissertation on this when she did a master's at CAT, and she found that the amount of heat loss through an open chimney was equivalent to spending tens of thousands of pounds on insulating your walls, your floors and your roof. So really the cheapest and most effective thing you can do is, if you don't use that chimney, I would block it up. If you do use that chimney, put something like a chimney sheet or a chimney balloon up it, so you don't lose the heat up there. And then think about ventilation system, which I will talk about in the second half. And the final question, so talking about humidity sensors. I think it's more just a comment from Di about the humidity meters. Another comment about those actually is that you can buy ones that log your temperature and humidity, so you can see the changes over time, a bit like that graph I showed a couple of slides back. So you can get ones where you can just see in the moment what your temperature and humidity is, but you can also get ones that log. And actually, I wonder about inviting Matt in at this point because he has done a bit of research on this. Sorry to put you on the spot, Matt.
Oh. Yeah, hi folks. Yeah, so there are lots of options for temperature and humidity sensing. So there are the ones we've been using most recently are the little they're called Acquia. I'll put a link in the chat. I've put a link for the chimney sheep in there as well. But they're very cheap, and you can get either ones which have a readout on, or a slightly cheaper one which you just read from your mobile phone, and they're really tiny, so you can just place them all around your house. And so I've just put a system in here where I'm doing that for all the rooms in my house, and it's really helping me to understand how the house works. And they're around about £10 a piece.
Okay, great, thanks Matt.
So yeah, no problem.
Does anyone else have a question while we're stopped before we get into the next section? You can put your hand up and speak, you don't have to type. Okay, so the next section, standards and regulation. I have to say, as we go into this, I don't come from a sort of architect or building professional background, but I sort of know some basics which will certainly help sort of a lay householder find their way around this. But there may well be people on this call who know more than me, and I really welcome your comments in the question and answer section as we talk about standards and regulations. So the things to be aware of, there's building regs, which everyone has to meet. There are some standards within passive house certification around ventilation. There's AECB, which is the Association of Environment Conscious Building, and they have some standards around ventilation. And there's also some building reg information around fuel burning appliances. So I'll just have a brief look at those to give you a sense of what needs thinking about when thinking about ventilation. So building regulations, the key requirement is to not make things worse. But in retrofit, you'll be making big changes. So the parts to be aware of, you've got part F, part J and part C. I think the thing to be aware of with building regs is that they're not that great, so you really have to meet them, and it's not that, I don't think it's that hard to meet them, but really you want to aim for better than building regs. They are in consultation at the moment, and we'll wait to see how they change from that. But if you want to find out more about those parts, just follow these links. Let's see. So things with ventilation systems is they work. It's a whole. We sort of want people to sort of consider as a holistic thing around how they work. So I don't know how many people have had. Certainly in my house, we've had an extractor fan that's too noisy, and people switch it off at the isolator switch, and then it's just off for a couple of days till someone else has noticed and pops it back on at the isolator switch. I don't know if there's hands up how many people have come across like extractor fans that are too noisy, and so therefore they actually don't end up using them. Yeah, a few people. So I think when considering systems, it's good to take a more holistic approach than what building regs requires of you, because really you want these things to be usable. Things like passive house have a sort of tougher standard, so I'm not expecting you to read everything on here, but sort of, and even if you're not aiming for a passive house, so anyone that doesn't know, passive house is a sort of a standard of building that's sort of incredibly efficient. So even if you're not aiming for something like a passive house, you can look at what the kinds of things that they stipulate, and then that might support you to understand sort of some of the wider issues around what you might be looking at when designing a system. So for example, how controllable is your system? Is there ventilation in all the rooms? How to deal with excessively low indoor air humidity, which is not often a problem in Manchester, that's for sure. Sound levels, so again, what I was saying about ventilation being too noisy and therefore not very usable. And also drafts, sometimes ventilations can cause uncomfortable air movement that isn't pleasant to be around and makes you feel uncomfortable. So there are more things to think about in ventilation than things that come up in building regs. And so yeah, these are good things to look at. There's also a bit more information in the AECB building standard. So if you follow these links and have a look, as I said, this isn't my expertise, this area, so I won't be able to answer any sort of detailed technical questions on them. But certainly there's information here that you can follow up. And then if you have fuel burning appliances, obviously they have to be gas safe, and there's heat standards as well. So earlier I was talking about air tightness and ventilation. Sorry, oh, there's my box diagram. Right, so earlier, let me just, oh, there's a question here. Is passive house same as passive house? Yes, it's just German or English spellings for it. So I'm just moving the chat box so I can see the screen. So if we're thinking about our ventilation systems, the leakiness of the house actually makes a difference to what kind of system you might decide to pick. And if you've got a more airtight house, you're probably more likely to need something that's got a continuous ventilation, mechanically assisted ventilation. So on this graph, on this sort of table here, you can see a rough sense of how leaky different kinds of houses are. So the average house hasn't really had much done to it. Is likely to be 12 to 20 sort of meters cube per, yeah, I won't read the whole thing out there in terms of how air permeable goes, but if we go for the figures of between 12 and 20. A new house is supposed to be, supposed to have sort of 10 as the sort of rate. Often new houses are actually worse than that because there's sort of issues around checking the houses, sort of whether all the houses on a new site get checked or whether it's just one that gets checked that the construction firm spent a lot of time on or not is a thing. But anyway, that is what it's meant to be. Good practice is around 5, best practice around 3. If you're going for an incredibly tight house, that might be the AECB building standard NFIT or passive house. So NFIT is essentially a slightly more only slightly more lenient standards than passive house, and that's kind of for retrofits, recognizing it's hard to make so passive houses are often new builds, whereas retrofits, someone wants to sort of improve a retrofit to a really high standard, they might aim for something like NFIT. And in these standards, they use the term air changes per hour. So the reason I'm sort of bringing all these figures in is as we look through the different types of systems, you can sort of have a sense of what your home is like and what kind of system may or may not be appropriate to you. So this was my funny little diagram that helped me understand the relationship between air tightness and ventilation systems. Just this idea that if you have a drafty house, so say this cardboard box is actually a house, you have quite uncontrolled airflow and it's quite unpredictable and inefficient, whereas in a very sort of airtight house, it's very controlled and predictable and efficient. So yeah, just a reminder that a drafty home doesn't mean it's well ventilated. And I guess the point about this again is if it's impossible to make your home very airtight, like the home that I live in is, you know, it's a big old built in the sort of 1850s or something with lots of different parts of the house. That would be a real pain to make it airtight. Therefore, we probably wouldn't go for an incredibly expensive, complex ventilation system because it just wouldn't work very well. And this is kind of what I was talking about, the relationship between how airtight your house is and what your ventilation system is. Whereas if you have a very sort of simply constructed, maybe 1960s boxy type construction that it wouldn't be so hard to make it airtight, then that might be, you know, it might be easier for you to consider sort of a more complicated system. So we'll move into the systems and interrupt me if I've missed a question. So there's lots of different systems to choose from. Some of the things to look at are whether it's mechanical or passive, whether it's whole house or just in a single room, and whether it's extract only or supply and extract. So I'll explain a bit more about what all of this means as I go through the systems. So the first type is this kind of supposedly natural system. where we don't have any mechanical extract fans. It's just we use windows, and so the background ventilation in this case is sort of windows opening, and the purge type is just opening those windows wider, and being slightly sarcastic. This is quite a simple system, but I guess the problem again is it depends on the weather, how windy it is, as to whether you're getting a decent airflow through your house, subject to human error. Did you open your windows, or did you open your windows for too long, and then there's security issues there. There's no guarantee that you're actually ventilating your whole house, or that there are parts that you're missing. So it's not really adequate in terms of providing good air quality. And also you're probably losing a lot of heat and making your home quite cold, which again, as we talked about earlier, you'll have issues with mold and other types of issues. So it doesn't really cost anything. We're not quite sure how suitable it is for what kind of airtight level. But I guess the reason to put this in there is just to acknowledge that this is the case for some people, that their ventilation system is to have windows that open. We don't really recommend it. So this is probably a fairly common system, intermittent extract. So what this means is that your background ventilation is through trickle vents that might be in your walls or in your windows. And then the purge vent is where you have a fan in your bathroom or your kitchen, which are activated just by a switch. So when you switch the light on, the fan goes on. Or they might be humidity controlled, so they're off, and then when they sense humidity, they boost up. This is quite simple and cheap to install and run, but we don't really think it's totally sufficient to ensure that you've got good air quality, and it's not appropriate if your homes are very airtight. And as we were talking about earlier, it can be quite noisy, and it can be, you're bringing lots of cold air in, so it won't necessarily be comfortable. But if your home is sort of 5 meters cubed per meter square per hour, so that was kind of probably most typical homes. This is, you could have a system like this, but it wouldn't necessarily be, if you can, there are other options that are possibly better than this. Stop me if there are questions, because there's lots of information here. Another system is a passive stack. So this is not mechanical. It uses sort of passive, it's sort of, you have a designer who will sort of look at your home and sort of explore how they can encourage air to move through your house. Usually you have your inlets in your sort of dry areas, so your living room or bedroom, and then your pool sort of air, warm, moist air, and air from other parts of your house through some kind of stack mechanism. So I guess they could use chimney, or sometimes they'll put in ducts. So the background ventilation is this sort of hot air rises, pulling air through your house and creating this pressure difference. The purge vent is sort of opening a window, or sometimes you can get fan assisted ducts. They can also be humidity controlled, so you can get sort of vents that react to the humidity and temperature in the house, that control how the air is moving. So because there's very few moving parts, there's very little maintenance required, which is definitely a pro. And as I said, it can be demand controlled with these kind of humidity controlled ventilation, and they don't use any energy. Some of the cons with them is that they are weather dependent. So on a still warm day, they won't necessarily work as well as on a cold, windy day. And you might feel some drafts from the intake vents. And so I know that I do know one of our members who had this system installed and found that it generally worked. It was just, it didn't work well enough in the bathroom, for example, and they had removed their extractor fan in the bathroom, and then found that they actually wished they hadn't done that and kept that extractor fan in along with the passive system. But again, it's not really suitable for an incredibly airtight house. It's probably be suitable for sort of probably most normal houses that haven't had lots of airtightness work, and they sort of don't cost huge amounts, but they're not cheap either. So it's not the most expensive system. There's a question here from Di. Yeah, they could have an energy cost through heating. That's potentially true. I mean, I guess with demand controlled vents, that is managed because it will open at the appropriate humidity and temperature. But yeah. Positive input ventilation. So this system involves a fan being placed inside your loft, and it brings air from the outside. I think they sometimes say they put it through a filter. They push it into the house. And the idea is that they pressurize the house, and then warm, moist air can leave through through gaps. So when I first heard about the system, it was actually in a sales talk with a company that sold it, and I kind of left that sales talk thinking, wow, this is a system for my house. This is brilliant. Came back to the office, talked to some people there, and realized some of its issues. Actually, I'm kind of talking through this story, I guess. So yeah, the part of the problem is that if you're pushing air into, you're pressurizing the house and pushing air, you sort of think about where all that warm, moist air is going. It might go through some sort of extract trickle vents, not extract, sorry, just trickle vents, but more likely than not, they'll go through the cracks and gaps in your house. So remember earlier about when I talked about interstitial condensation, you end up pushing warm, moist air into the building fabric, and then you might end up with lots of issues around sort of mold growth behind, sort of around sort of your joist ends might have problems, or if you've got insulation, particularly problematic. And I think this is a system that's also because it's bringing cold air in, it's used a lot in various social housing contexts, and people's energy bills have actually gone up after installing systems like this in some cases, because sometimes the fan will heat the air as it brings it through, but then use more energy to heat the air. So it can be quite costly to run, and it's a risk. I would steer clear of this kind of ventilation system if I were you. Other people might have other opinions. I don't know if you do, pop them in the question and answer, but I do think this is kind of one of those ones that sounds like an amazing quick fix and actually turns out to be a bit problematic. So centralized mechanical extract. So this is kind of like positive input ventilation in reverse. Again, you have some kind of central place of extracting air from your house, sometimes in the loft. It pulls, so the background ventilation it's constantly running, and there'll be a boost function on fans in sort of if it senses that it needs to pull more out, it'll boost. Some of the pros, there's sort of a limited number of holes in the building fabric, and you've only got one fan. Also, if you've got that fan in your loft, you can sort of buffer it, so the sound doesn't, you don't get that kind of noise issue with fans in the rest of the house. But it is a bit more complicated to install. You might end up having to put ducts around your house, and the supply of air is cold. But it's not a bad system at all, and I do recommend checking out AirEco, which is quite a good company. They'll do a sort of free house assessment to sort of check out costs, and we normally don't recommend a particular companies, but we do think they're actually not a bad one at all. And if you're a Carbon Cop member, you also get a discount, which is quite handy, 25%. So it's definitely one to check out. And again, it's sort of suitable for quite airtight homes, actually. So if you're doing, quite airtight homes, but also homes that are less airtight, this is not at all a bad system. There's a question here. So I guess that in terms of the systems, so the more complex systems, so for example, I'm going to talk later about MVHR, mechanical ventilation heat recovery. So I guess if a system's more complex and more expensive, if your house is very drafty, it might not be as effective as it would have been, which might mean that you've not spent your money well. If the system's less expensive and less complex, even if your home isn't very airtight, it will still do a job. That would be a worthwhile job to do. So as we go through the systems, you'll see that there are different ones for different types of situations, and actually hopefully that will help you sort of figure out what the best one is for you. Let me know if you don't feel like I've answered your question, by the way. So another type of system is decentralized mechanical extract. So this is quite like the intermittent extract, but with a sort of important difference. So the background ventilation is that there are So this system's made up of extractor fans in your wet rooms, so your bathrooms and your kitchens, but not in your dry rooms. There's a stray warm arrow in the living room that shouldn't be there, so just ignore that. But the idea is that you have this continuously running fans on trickle in your wet rooms, and then when you have high levels of humidity, say you've just had a shower or you're cooking, those fans will boost automatically because they're humidity controlled. So this is actually quite a simple system, and it's not very expensive, and it provides continuous ventilation. So for a home that's not very airtight and is quite drafty, this is not a bad one to consider. You can also get low noise fans, but you know, sometimes noise is an issue, and this is one of those cases where if you've lots of people in a house and not everyone's similarly minded about the importance of this, you'll get people switching off fans. And also, again, the air supply is cold. But again, you know, if it's going to be tricky for you to do sort of high levels of air tightness work, you know, this might be one for you to sort of look at. I think there's another question. Let me just have a look. You can have a heat exchanger, so that is another system. So I will talk about that in a bit. Can trickle vents be installed into? So that's a tricky one. I would go to a window installer. I think PVC is particularly difficult because it's hard to adjust. I don't know if anyone else has had experience heat exchanging the fan. Yeah, no, I do understand that.
Sorry, if I could just jump in on the UPVC double glazing. Yes, you can fit trickle vents into double glazed units. Last time I checked, Screwfix actually sell them.
Okay.
So yeah, but they are fiddly to fit. You should probably go to a window installer to have them done. Sorry, I'll go back on mute now.
Also, if anyone else wants to ask a question person, you can do that. We don't have to stick to text. I like to hear other voices to know you're there, you know. So, please can you save them? Otherwise we have to keep. Oh, save the questions. Yes, I will do. Thanks for that. So I'm going to talk about mechanical ventilation heat recovery. So this is a system where you have a unit somewhere in the house, sometimes in the utility room, for example. You'll have a constantly running extract from the wet rooms to that central fan, and then that warm wet air will warm up cold air coming in from the inside to supply warmed up air into the dry rooms of the house. So it has, you know, a boost function of the fan to deal with purge ventilation when that's needed. There's quite a lot of pros to this system. So there's only a limited number of holes in the building fabric. Again, I think it's just the extract and intake to that one system. You don't have issues with noise from outside because, generally you don't have to have the windows open so much with this kind of system. It's incredibly efficient if your house is airtight. It's not necessarily efficient if your house isn't airtight. But obviously it's good on comfort. But I wouldn't go around and say everyone should have this system because it's incredibly complex and expensive to install. And actually, if you don't install it well, it won't necessarily work well. You really need good quality design and detailing. And it does require maintenance. I guess, yeah, again, if you are going for very high levels of air tightness in your retrofit, if it's anywhere below 1.5, you have to go for this system if your house is very airtight. But if your house isn't very airtight, I wouldn't necessarily suggest that this is the system for you. There are cases where if you live in a very sort of there's a lot of air pollution outside, because the system has a filter, that might be appropriate for you. Or if there's a reason for why you don't want to open your windows, again, because of air pollution, that might be a reason. But again, it's incredibly expensive. So it's sort of the capital cost is £4,000. That doesn't include sort of installation costs. So it's kind of like a incredibly complex and efficient and interesting system, but not necessarily one for everyone. I don't know if anyone wants to add in more at this point, because often lots of people have things to say about MVHR. Okay. Another option is decentralized MVHR. So this is where you have heat recovery. So your extract and your intake are in the same sort of space in that same tube. There's a picture there underneath the sort of image of the house. We've actually ended up installing this in our house. So the background ventilation is constantly on trickle, pulling sort of air from your room outside and pulling, sort of supplying, cold supply air comes in and gets warmed up by the air, or by the warm, moist air leaving your house. And it will boost when there's high levels of humidity. It's very simple to install. And obviously the heat recovery improves the energy efficiency. So that kind of question of how do I balance not wanting to lose energy, but also wanting to have good air, good air quality, this is potentially a solution. But having had it installed in our house, where we've installed it in the bathroom upstairs, we have a sort of shower, and in our kitchen, I think we made the wrong decision actually, because we considered this as a product where we thought, wow, this is great. We get to save some of the heat. So that's quite good in terms of energy. So this is quite a good system for us, isn't it? But actually it doesn't, if you think about wanting to manage the airflow through your whole house so that there is good indoor air quality, thinking about all those things from the beginning of the presentation, say there's VOCs and things like that, actually it doesn't pull air through the house. So in our house, those 2 rooms are incredibly well ventilated, and it's kind of stopped lots of the mold issues that we used to have in our bathroom. But my bedroom isn't very well ventilated by it. Sort of the living room isn't well ventilated. The hallway isn't well ventilated by it. It only really works if you put one of these units in every single room. But then if you start adding up the costs, so it's £300 per unit, and say you've got 7 rooms, suddenly that's actually quite a lot of money, and one of the other systems might have worked well for you. I think if you lived in a flat where you just had 1 room, this might actually be a very good system. But I think I learnt lots by making the wrong decision in our house, and I think we should have gone for the decentralized mechanical extract. That's where you have a fan that's on trickle all the time that boosts with humidity but doesn't do the heat exchange. So I can see there's lots of questions, so I think I'm going to have a go at answering them. So one from Amandeep: do the performance of these fans degrade over time? I think one of the issues you have is maintenance. So if they aren't well maintained, their performance will decline. So you have to keep on top of maintenance. We'll find fans that aren't maintained well. Let's see. Could you say something about cooling options in warmer climates? I actually don't know much about that, so I can't. But I don't know if Liam or Matt or anyone else on the call might have an answer to that. If anyone wants to put their hand up. Okay.
I would say that when it comes to cooling, it's not something that in the UK anyone has really put any thought into at the moment. I imagine that they will be doing fairly quickly in the next few years, but as yet, there's not much UK information about that.
Yeah. So I think I've answered the heat exchange and fan from someone called User. What's Andy Walker said, around 30 minutes per trickle vent. Do you want to explain what you mean? Here we go, and we've also got User. I don't know if Matt, you can unmute some of these people that want to talk.
User, you are unmuted and ready to speak.
Hello.
Hello.
Hi. Yes, that's you. You're on.
Oh, hi. Yeah, just with this circulation through the house, what's it like about leaving doors open? Does it depend on the size of the rooms?
Oh, hi, Phoebe. I recognise your voice. Yeah, so generally, normally doors have a little gap underneath them to support air to circulate around a house. So you don't necessarily have to leave your doors open.
Right, thank you.
No, no problem. I don't know if Andy wants to explain his comment. Maybe that will come in a bit. So
I could answer that.
Yes.
Okay. Hello, everybody. The whole ventilation issue depends on the house. I recommend to my customers that they consider individual room MVHR in the wet rooms and then trickle vents in other rooms. And my customers report that that is produces a very livable air quality space and no problems with ventilation. In terms of retrofitting into an existing window, it is a matter of cutting a slot or a series of drilled holes and then putting the vent on the inside and the cowl on the outside, and that takes me about 30 minutes.
Okay, thanks, Andy. Yeah, I think with our house in particular, it does all of this. It really does depend on your house. We've got quite a large house that's quite higgledy-piggledy with lots of bits. So I don't feel like in our house we're getting a good airflow through the house with our MVHR in the bathroom and kitchen. But I think if you had maybe a simpler construction, like I said, a flat or even just a simpler form of the house, possibly it would work better. In terms of noise, actually, no, we're getting quite a lot of noise from our fan. So it does depend. You do get ones that are low noise. I think part of the problem is we haven't maintained it very well. And so it's getting noisier. So yeah, that's still an issue. I think probably if you really don't want a noisy ventilation system, probably going for something where you can buffer the unit somewhere, acoustically buffer the unit. That's sort of providing the extraction. That would probably be the best option. Okay, well, thanks for your input, Andy. I'm gonna move on to the next system. Oh, that might be the last system. So we're quite ahead of time, which is good. So some quick wins. Definitely everyone should, if they've got any fuel burning appliances, get a carbon monoxide monitor. I'd highly recommend getting a hydrometer, possibly the one that Matt suggested, so that you can actually monitor your relative humidity. Simple things like if you've got trickle vents, check that they're open. Check that you're sort of, when you say manual switches and talk about the isolator switches, check that they're on, that someone's not switched them on. Clean your fans. I should take my own advice in our house. Certainly if you dry your clothes around your house, I would consider strongly not doing that. And if you don't have the option of drying them outside and you don't have a dryer, dry them in one room and ventilate that room and keep the door closed. So maybe your bathroom with the extractor fan on, or possibly a dehumidifier. Some people do that. Again, it uses a lot of energy. You know, reduce the amount of pollutants you're putting into your home by using low VOC paints and putting your lids on pans and things like that. There's some quite simple things you can do. But hopefully this has helped you understand systems better. Again, it really depends on your home and your situation. I think, given that we've got a fair bit of time, what time are we on? We've got a good half an hour, so we can finish early, but also it might be nice to hear from people, any thoughts they have, any questions they have. There's probably quite a lot of knowledge in this webinar of the attendees here, so do feel free to speak up if you've got any questions. Yeah, go for it, Andy.
Right, I got it. So, hello, everybody. I thought that was a great presentation. I've really enjoyed that, and I've learnt some things, which is always good.
Thank you.
What I'd like to add from my experience of doing energy reviews and installation is the suggestion of drying clothes in a bedroom. I'm slightly concerned that that would actually be putting moisture into a living space and could well cause problems in that room. I'm going to offer the alternative suggestion of using a bathroom.
No, yeah, sorry, that is what I meant. I apologise. Yeah, I wasn't suggesting to dry clothes in a bedroom. Okay.
So putting it in a bathroom, what I often say to people is that not only could you, if you haven't got a ventilation system running, but keep the heating on low, open the windows slightly, but the key thing is to have an auto door closer on the bathroom door. And I'd also put draft strip around that door. In other words, isolating the moisture burden that's being created in the bathroom from the rest of the house. So that's a suggestion I'd make.
That's a very good suggestion. Thanks, Andy. Yeah, because essentially you want to stop that warm, moist air getting into the rest of your house, really.
Yeah. The thing about the doodly kind of diagram about how condensation works, I slightly disagree with the primary statement that was made that it's moisture in the air that causes condensation. I'd actually expand that to say that it's the combination of moisture in the air, cold surfaces, and not enough ventilation.
Yeah.
And it's about improving 2 or more of those, at least a bit, so you can get rid of the condensation. Insulation or fabric first is can't be overemphasized as a way of reducing energy and reducing carbon in the country, and that immediately warms the surface up because you haven't got a heat flow through it. So I definitely favor that. One of the things you said, Aniaka, about the drafts caused through downlighters, I mean, they're problematic in several ways. Not only does it cause an issue in terms of how you put loft insulation above them, but you do have this airflow through them. Yeah. What I found works really, really well is in persuading people to move from the old style halogen bulbs to LED downlighters is at the same time to have all of them as shower fittings. So the luminaires are the same as what you'd put in a shower fitting. And they are, of course, not only waterproof, but completely draft proof. And that removes the problem altogether.
Oh, that's an interesting suggestion. There's also some people sort of put loft lids, so kind of little caps you can put on top of your downlight from the loft side and seal them in and put insulation over the top of them.
Absolutely, and that it can be done even easier by putting a board between the adjacent joists, putting insulation up to the edges, and then another layer of insulation on the top. The UK building regulations of 270 millimeters isn't really enough to give you a proper woolly hat on your house, and I really aim more for 400 or 450, because that's really getting you down below a U value of 0.1 for the whole house.
I'd really support that. We always recommend about 400 mil of insulation in the loft. So, yeah.
Absolutely.
Thanks, Andy.
No, that's really very good. Yeah, that's it.
Okay.
Thank you.
There's a few other questions here in the question and answer box. So someone said, if you live in a flat, would you be considering the same kinds of issues? Can you expand on your question, because I don't fully understand what you mean. Let's see, I think that might be Laura. Is she there? I'm not sure she's there. Okay, I'll move on to the next question. I've encountered 2 clients who had damp patches around a capped chimney, possibly the result of hygroscopic salt. Is there anything can be done about this? One was a homeowner, the other was privately renting. I don't know if, Liam, you have something to say about this.
There's a lot of complications to do with chimneys, and basically if you look online or speak to anyone who knows anything about it, you can find 2 equally respected people who will say absolutely the opposite thing. As a rule of thumb, the best thing that you need to do is have some kind of ventilation into the chimney, which can to some extent cause drafts, but it's more about making sure that you haven't got moisture coming through, and it can actually cause structural issues if you've got damp and condensation around the chimney stack. So really, there's not enough kind of information to go off there for it, although I'd be happy to discuss that with them at a later date if that's any use. Sorry if that's not much help. It's very complicated with chimneys.
I think Andy wants to say something again, possibly about that issue. Okay, well.
Yeah, okay. I have to press the button before I start speaking. It's crucial to have an airflow into a capped flue, otherwise you can definitely get moisture buildup. The trick, though, is to not source that air from the living space. If it's possible to take it from a different space, either by putting a hole in the subfloor void, or in one case that I did, I actually pulled a pipe out of the bottom of the first floor flue and ran it between the floorboards to the outside. So this gave ventilation, but without drafts.
Thanks, Andy. Yeah, one suggestion someone gave me was to block my chimney, but put an air vent into the cold cellar space and then the cold attic space. So that there was that same, I think I had a similar idea to you in terms of there being an airflow through the chimney that was out of the heated space.
Yeah.
So there are ways around it. But certainly they do need ventilating. Di has a comment here. There is or was another kind of decentralized MVHR with a pair of units maybe in different rooms linked with Wi-Fi. So one inhales while the other exhales, and they store heat from the exhaust air to put into the inhaled air. But it was very expensive when he looked into it. So that's an interesting point. I don't know if you'd like to say anything more about that, Di. But I guess this is kind of giving you some kind of basis on which to do further research on these things. I don't know if Laura, you're still there and you want to explain your question about flats. I think certainly in any living environment, you're going to need to think about ventilation. Obviously, because it's, you know, you wouldn't consider something like passive stack because that requires some height for the chimney effect of the passive stack to work. So that wouldn't be a system that would work for you, but certainly you'll need to think about different kinds of, you know, you'll have to think about what the appropriate ventilation is for you. I don't know if there's something else you meant by that question. But you're muted. Does anyone else, oh, someone else has an air brick going in from inside to the outside of the chimney breast. Is that bad? So that's air ventilation going essentially from outside into your chimney breast and into your house, or from inside your house? I mean, both ways, essentially. Is that what you mean? I mean, yeah, it'd probably be more ideal for you to have an air brick going from inside to inside the chimney breast to outside again, rather than connecting the inside to your house and then outside. But again, I think with chimneys, I would contact a building professional and find out what the best thing is. I don't feel qualified to answer that question myself. And I don't, every situation is specific, and there might have been a reason why that was done that I don't want to suppose. So, ooh, lots of questions. Are there any simple ways to measure other air pollutants such as particulates or dust mites when pets? That's a good question. There are lots of ways to measure different kinds of air pollutants, but as far as I can understand it, those are they're more expensive, and the simplest way you can measure is through using hydrometers to look at your humidity. And I know that's not what you're asking, but it's the sort of simplest way to get a sense of whether you've got good levels of, if your house is well ventilated, you'll probably have, you know, well ventilated as well as heated, you'll probably have good humidity levels. Whereas if you've got quite high levels of humidity, you can probably assume that, you know, your ventilation system's not working so well, and therefore you'll probably have other air pollutants hanging around. Is the way I would answer that myself, but there might be other opinions here. And there might be other knowledge about other types of ways of measuring air pollutants that are inexpensive. Matt's kind of did a bit of work on this, I feel like. You want to chip in, Matt? But maybe he didn't. Okay, Matt's not there. So whether are there lots of recommendations for houseplants improving air quality? Do they really? I mean, so houseplants definitely lower the, how do they work again? they take in carbon dioxide and release oxygen, don't they? So in terms of carbon monoxide and carbon dioxide, sorry, they're quite good, but they also do release humidity. So I found that in my room with lots of houseplants, I actually have high levels of humidity because of my houseplants. So I don't really want to get rid of my houseplants, but that kind of means I need to think about ventilation more. So it's a balancing act, I think. So answer to that question. There's another hand. Yeah, do you want to speak, Omen? I think you have to unmute yourself.
Yeah. Just a quick one on houseplants. Obviously with a lot of foliage, the leaves themselves collect a lot of particulate matter. So when you're hoovering, and I think hoovering is actually quite good for air pollution. You can, if you put it on the lowest setting and actually hoover the leaves, or use a wet cloth on leaves, it's pretty good at picking up particulate matter.
So you're saying that plants, because they attract things like dust, you can use them as surfaces to clean to reduce the amount of, is that what you're saying?
Yes, yeah, pretty much.
Right.
They have a larger surface area than just flat surfaces.
I'd not considered that part of houseplants, thanks, Simon. Laura's expanded. Sorry, I'll try and expand. I was just wondering whether these tips for analysing improving energy efficiency, air quality, ventilation would be equally valid if you live in a flat, or whether they're specific to houses. I think they would be equally valid if you live in a flat. There'll just be slightly different parameters of things that you have to think about when you're in a flat. So obviously, so I'm actually in a flat at the moment in the Red Bricks in Manchester. So in terms of, and we did some energy efficiency, home energy assessments on these flats. And because you've got less wall area, so in houses, you know, wall insulation is probably a big area of heat loss. In a detached house, certainly in a semi-detached house and terraced house, as you can imagine, the amount of walls that are sort of exposed to the external walls will be reduced. And certainly in a flat, you don't have many external walls. So in that way, so in these homes in particular, the biggest source of heat loss were drafts. So things like draft proofing might have a bigger impact. Well, they do have a bigger impact in the flat that I'm in at the moment because of the particularities of this flat. And also it used to be, the heating system used to be coal fires. So they have big air vents in the walls, but now they've been converted to central heating, and lots of those big brick air vents in the sort of walls haven't been blocked up. So you end up getting lots of drafts coming through. So but that's just this particular flat. So I would say that in any home, whether it's a flat or whether it's a detached house or whether it's a terrace, you can't really sort of say that type of house there'll be definitely those problems, because every home is unique and will have their different issues with them. But there are some commonalities, for example, less wall space in a flat, for example, when you don't have a roof and you don't have sort of floor issues, but they might be concrete. You know, in these flats, again, there's a balcony that goes out that are built out of concrete, and there's it kind of acts as a big thermal bridge, because the floor of the kitchen that goes out into the balcony is sort of all one unit. So that sort of, if you imagine a cold bit of concrete out in the cold air, sucking lots of the heat out of the house, essentially. So again, that's a particularity of this flat, but often flats often have balconies. So yeah, I don't know if that's answered your question. I feel like I possibly waffled a bit. But every home's different, but there are, yeah, I don't know if there was why you were asking that question, whether there's something else that you want to find out. But certainly in terms of air quality and ventilation, it's very, like, this is relevant in any place that a person lives in, I would say. So we'll take the last few questions if anyone has them, and then we'll wrap up for this evening. Anyone you can either put up your hand or pop the question in here. Great, you ask. Okay. Any hands? Okay, well, I think I'll give everyone another minute to say something or put up a hand. And then I think I'll wrap up. Okay, well, thanks again for attending. Oh, there is a hand. Oh, it's gone down. Thanks for attending. Oh, actually, before you go, so we do have the final poll. So I don't know if Matt, you'd like to put it out. So this is the first time I've ever done a webinar, and it would be really useful to hear back from you, one about the content, but also about how you found a session like this. So there's a feedback form that's just popped up on your screens if you don't mind filling that out. But also in the questions and answers box, if you don't mind, I would love it if you could just write something that you thought was good, something that you thought was less good, and any suggestions you have. It would be really helpful to share those. And if someone else has written something that you agree with, just sort of upvote it by clicking the little thumbs up symbol. And then we get a sense really of how this has worked out for you, and also how we can improve these sessions in the future. So it'd be really helpful if you could do that. Thank you very much. Oh, great, everyone answered very, thanks very much. It's nice to see. And if you could pop your comments into the questions and answer section, so just anything that was positive, anything you thought was negative, and any suggestions, that'd be brilliant. And there's Carl James who wants to say something.
That was a mistake.
Hello.
Comment.
Hi, Carl.
Just making just saying it was a nice, concise session, very clear. That's all, wasn't it? Anything else?
Okay. Thank you very much. Also, do feel free to make suggestions and say anything that wasn't so good. And I will share the slides and the recording with you as soon as we get it into our system. Okay, well, feel free to leave when you like. I hope you're all very well and staying safe, and maybe see your name pop up on the chat box as an attendee for another session of ours in the future, and maybe hear your voice or see your video until we can all see each other again in real life. Thanks again for coming.